RC Bro here again, and welcome back to part number 3 of upgrading the Deerc 9201E from a brushed motor to a brushless motor. I know a lot of you, while watching this, you may be thinking, this is a lot to do to get this, upgraded from brushed to brushless. Especially when you can just buy the same or similar model car that comes already with the brushless upgrade, the brushless motor. So the purpose is for us to learn. The more you do in taking apart the car and seeing how the parts work together, the more you learn how the car works. I don't expect everybody to try this, but it's good to get this knowledge, because the more you know about how the car, the motor, the ESC, the servo, the steering linkage, the drive train, which is the drive shaft, and the differentials and the gears, the more you know how they work together, the more you can take care and maintain your car and build on top of that knowledge. And a lot of this is introduction to mechanical engineering, the mechanical part. And when we get more into the electrical and electronics, it'll be an introduction to the electronics and the electrical engineering. Alright, so we're continuing with the servo. If you recall, we have to replace this servo because it has what's called a 5-wire servo. And the standard hobby grade servos that you purchase online are 3-wire servos. So for example, this servo right here has 3 wires. And what the main difference is that this doesn't have a control board inside of it. The DRC one, it does not have a control board. We focused on there, yeah. And without a control board inside of it, it has to be controlled by the software in the ESC that it's connected to. And so the software inside of here, which is programming, that controls the angles and how this performs without having a board inside, whereas the other 3-wire servos, they have boards inside. And so what we're going to do, in fact, this is a hobby grade servo. It's a real small one, but it's definitely a hobby grade servo, and it's 3-wire. And if you look inside, you can actually see how the servo works. If you look inside, you can see that it has a motor and it has gears, and I'm going to try to see, and it has a circuit board in there. Might be kind of hard to see, but it's a circuit board in there. You can actually see it, and you can see the motor. So that's all a servo is. It's a box that has gears and a motor, and the motor is controlled by the board, and the board is controlled by these 3 wires that go to the ESC, and it uses codes that are called pulse width modulation. And it's a simple, basic type of way of communicating, whereas this ESC is a little more complicated because it requires more programming. I'm sorry, the servo requires more programming. All that being said, here is the replacement. Let's see what appears. Here is the replacement servo that I purchased. And if I pull this one out and we can compare the two, this one is a standard sized, well, the base of it is standard. Most of the servos you get for RC cars are 40 centimeters by 20 centimeters. And so this part is standard, but the height is lower so that it matches the height of this servo. And it's called a low profile servo. The one I purchased previously has the same size base as this one has, if you look at the bottoms. However, this one is much taller. So this one is not this is a standard one, but it's not low profile. This is low profile. So my challenge is, how am I going to fit this slightly larger servo into this slightly smaller hole? right here. And what my plan is, and there's another concern too. I think I've solved that already, because this servo is longer than the old one. I need a longer steering arm, so I have a longer steering arm to go on this servo. So that problem is solved, but I have to solve the problem about fitting it into that slot. And so, but my plan is this. I'm going to try to angle this up so you all can see it real good. So my plan is, I plan on cutting out this wall right here, the front wall, where this old servo went. And I plan on cutting out this wall and cutting back these support posts. And so that gives me room coming further this way, and also gives me room going further back. And then what I'm going to try to do is put some holes into the chassis, and I may or may not use these posts, and screw down the servo. So that's what you're going to be seeing me do next, and hopefully we'll be able to get the servo in and move on to firing it up with the transmitter and receiver. Okay, so in order to do this, I'm going to use a combination of two tools. What we have here is my handy dandy utility knife, and I'm going to use that to make cuts here, I hope to. And this here is what we call a Dremel. This is a Dremel. It's an electric one. They make them battery operated. This is my old tried and tested true electric one. And it has a small blade on it. It's actually a metal cutting blade. It's not really a blade for cutting plastic, but it will do. And they generally are much larger than this, but this is the smallest one I have. It's worn down to this size. It originally was bigger, but it's been used so much it was worn down. And so I'm going to try to fit it in here to make the cut of this front wall, and then maybe cut the rest of it with my knife. So you're going to see me get this done, or you're going to see me mess it up. So here we go. To be real careful, because I don't want to cut a hole in the bottom of the chassis, so I didn't do that. So now if we take a look, this should bend a little bit. There we go. See, a bit closer. So now I'm going to take my knife and try to cut some more out. Neither one of the tools are optimum size. They make knife kits and knife tools. That's really what I need. But I may have to get something, because this is quite challenging.
want to watch your rep.
Okay, so what I'm doing is I am recycling these posts. If you recall, these two posts, I cut them out from here and here. These two posts were on the back, and they actually, the two posts held the back of the old servo in. These posts right here. I cut them out to make room for the new servo. But because I cut them at the bottom, I can recycle them to secure the new servo. So my plan is, I've drilled them out. They were too small, so I got a 1/16 inch drill and drilled them out with the 1/16. They already had a hole going through, so it was pretty easy. So I cleaned it out with a 1/16 inch drill, and then I took a 3/32 drill, and I drilled it out with a 3/32 drill. I think this is it, 3/32. Let's see. I think that was it. Yeah, that was it, 3/32. And what that does, it makes it bigger, so I can put a screw. I can put a screw in them. That's the idea. Okay, so what I have so far, I went on to cut that rear post totally out, and I didn't know it, but it had a screw holding it in, but it's not a problem. So now I have a clear space, and I'm putting the securing posts here and here diagonal, because it'll give it more strength if I do it. It covers more of the servo if I do it diagonal as opposed to one side. Alright, so you see that the servo is in place. What I did was I was able to reuse the posts that I cut out last time to secure the servo. I put screws in the top of the post. I drilled holes on the bottom of the chassis, and I have these two screws securing the servo. There's a screw here for the battery mount post, very close here, but it was enough to grab it. Going forward, I think what I'm going to do is I'd like to get a metal plate similar to this one, and then use some metal or steel metal posts instead of the plastic ones, because I can only tighten these so much because they're plastic, and you don't want to force them. You don't want to force them and over screw them, because you can strip out the threads and that would cause a problem. But it's in pretty good, and it's actually connected to the steering linkage, and I can actually make the wheels turn by turning the servo there. So now, also what I've done was, you see we have some Velcro straps here, and so I have to use Velcro straps because if you recall, I had a post that was right where the back of the servo is, right here. There was a post here, and it was a battery mounting securing post that had a pinhole in it, and if you recall, I cut it by mistake, but I had to remove it anyway. So I had to take that post completely out, and it worked well because it made space for the servo. And what I found out in looking at the car, they had already made holes in the sides here for straps. However, I had to cut straps on the inside right here and here. So I cut straps with my Dremel and my knife, and so I was able to get the Velcro straps in, and it is ready to hold the battery. So that part's done. Okay, hear that sound? You know that's good news. So it was actually easier to calibrate the servo endpoints than I thought. This particular controller, the Dumbo RC, actually has buttons for all that, and it actually makes it much easier. So basically adjust the buttons, and they adjust the endpoints and the trim and set the wheels straight just by turning them. They also give me the ability to set the maximum speed as well. So that actually made it quite simple. Just don't want to hit them by mistake, and I assume that's why they have this cover on here. But now, if we look at the wheels, I'm going to turn the car. Well, before I do that, let me show you what I've done to get it ready to run. Okay, so I actually tied, everything's hooked up. The support rod and engine cover, the support bracket is screwed in, it's back in place. I tied the wires together with zip tie, and I also secured the antenna. It runs the length of the car. And you see the ESC wires going here, and the servo wires going here. And the battery is in and hooked up, and the car is ready to go. Only thing that's not hooked up is my lights. This is for the lights. Because it doesn't have the proper connector to go in, I have to put this connector on it to make it work. And so we're not going to do that for now because I want to run it. So now we're going to look at the wheels and the steering linkage and the servo to see how it operates, and so I can show you what I've done. So as I turn, let's see how I'm going to do this. Okay, as I turn the steering wheel, you can watch the servo. And as you can see, there's no stress. I'm not bottoming out. I'm not slamming the steering linkage either direction. But it's got the full turn. And that's what we want. And it's very responsive, as you can see. That's what you need for a fast RC car. Now, I'm going to run the motor. So, check it out. It's forward. Reverse, brakes, forward, brakes, and this is just 75%. It's not 100%. And the steering. So now we're going to take it off my jacks, my custom-made jack stand, so you all can see the steering. Looks like my servo is working. It's not slamming, so it's looking pretty good. So, we are ready to test. Okay, the DRC 9201E upgraded with brush first run. The DRC 9201 first run. It is much faster. But it is having some problems, which I think are programming problems. On the low end, it's just starting out, it has a problem that's known called cogging, which makes it start rough, but once it gets going, it's like super fast and the handle is super good. I love the way it handles. But the low end starting off is a problem. And then when I punch it all the way down, for some reason it stops. But the acceleration and the operation is great. So, this first run ended up in disaster. While the car ran pretty good when it ran, um, it was suffered some cogging, which I think could have been fixed through programming. But the problem was, I'm unable to get the programming card to work with this motor. So this is what happened. I ran it, and I ran it and ran it on one charge. And usually with cars, they stop when they reach the low voltage, and you know you have to stop. But this one, it ran and ran, and it started to slow down. And so I noticed it was slowing down, but it did not cut off the car. So I turned it off, and I started hearing strange sounds, and I started smelling something. So I immediately turned it off and immediately disconnected the battery, and the battery was hot. The battery was hot, and the engine was hot, which is not unusual, but it is unusual for the battery to get off. So what I decided to do, let's test the battery. So just to let you know my meter is working, I'm going to take a 850 milliamp battery just for testing purpose to show you that my meter works. It's showing this battery at 7.7 volts, and if I go through the cells, got 3.8, 3.8, 7.7. So if I pull this one out and put the other battery in, look what we have. It's connected properly, and nothing. This battery is dead. So either the ESC on here is not as advertised as being waterproof, or the default programming was so bad that it didn't have a low voltage cutoff set properly, and either case it killed my battery. So not sure if it's still working or not. If it's still working, I still might try to program it some kind of way, and if it doesn't, I'm going to start with replacing the ESC, and until I actually try to program it, I'm not going to totally discount this ESC combo, but if I can't program it, I'm not going to use it. And also, my recommendation for when you do decide to upgrade, pay a little bit more money and try to get a name brand or a one with higher recommendations. I looked at reviews of this one and people had success with it, but I must say it was the cheapest one, which is not always the best.